Welcome to our AskTOM Office Hours sessions for database in memory. Today we're going to talk a little bit about in-memory aggregation, kind of updates to in-memory aggregation, things that have changed. We did a session, and well, let me introduce ourselves first. So my name's Andy Ruvinus. I'm a product manager for database in memory, and we're privileged to have Ekrem Soylemez, who is a developer and architect with Oracle and probably is one of the most responsible guys for in-memory aggregation. So hopefully we're going to learn all sorts of deep and wonderful intricacies of how vector GroupBy works, which is what in-memory aggregation translates to at the execution plan level. We do have, so on our landing page, you've all seen that, but since you had to connect, Maria's not here with us today, but our previous sessions are on this page, and our resources, mainly our blog and our resources page associated with the blog, and some of our other information about database in memory, in particular our live labs. So if you find this interesting, if you want to try out in-memory aggregation, you can try a live labs session. You don't have to even sign up for the cloud per se. You can do the on-demand session, and you can try it out in the cloud on your own. But what I wanted to actually point out is within this on the next page, we did do an AskTOM session on in-memory aggregation way back in, I guess, May of 2018. So if you want to, we're not going to cover all of the basic intricacies of in-memory aggregation and how hash joins work and how they're leveraged per se. So if you want to go get a primer to that, you can go back and look at our previous session. This was meant to be kind of a follow-on, a part two, if you will, of updated material or things that have changed in 12.2, 18C, and now 19C. I don't think we'll touch too much on 21C, although Ekrem may throw out a few tidbits in that area. I don't know. But I wanted to make everyone aware that, that there are additional resources associated with database in memory in our AskTOM sessions if you want to go poke around with that. And with that said, I think I'll bring that down, and I have just a few slides. As always, my email address, if you have questions later, feel free to email me. You can follow me on Twitter, and I guess what we'll do is we'll continue on. I wanted to just kind of do a quick recap of in-memory aggregation, and then I thought we'd maybe chat about some new features, Ekrem. And of course, feel free to jump in if I either say something wrong or you can think of something that that's newer that that is maybe more interesting. One of the reasons I really thought this would be fun to do was that I've seen recently that in-memory aggregation is getting chosen more and more often. And so it really is key, which is actually, I thought about this, and one of the slides I tend to use is why do we care about in-memory aggregation? What's the big deal? It shows up as a vector GroupBy, and you don't see this unless in-memory is enabled. So only folks that have in-memory enabled would even see a vector GroupBy. In the past, we've had sort GroupBys, and then more recently, which is now not that recent since it's like, I think 11 is when it came out with hash GroupBys. But now we have something called a vector GroupBy. And the idea is that with database in memory, I usually tell folks we're really focusing on three primary areas of benefit to the execution plan. And that's if you're spending a significant amount of time scanning or filtering and function-based aggregations like mins and maxes of data, joining data, whether it's hash joins, typically with a filter predicate on the smaller table or the driving table, if you will. We get a Bloom filters, and so we can effectively turn hash joins into scan and filter operations. And then GroupBy aggregations. So rather than a sort GroupBy or a hash GroupBy, a vector GroupBy is available. And the big benefit there, although the join changes slightly, since we use key vectors, which we can talk a little bit about, is we actually do the aggregation as we do the scan and filtering operations. So we're doing the aggregation as we go. And and Ekrem, you brought this up yesterday, and I kind of tend to say this in presentations, is that the fastest in-memory query you can have is one where we do all of the work scanning the data. I was going to say filtering, but realistically joining, aggregating the data, and we just return the results. And so that's the ultimate database in-memory query. And I think you brought that up as well. So,
yeah, that's exactly right. And I mean, kind of just to take this to sort of make maybe a little more expand on the idea with what IMA does, I guess in general, is it's really focused towards if table A in this example is a lot smaller than table B, the smaller table, or there could be many, smaller tables you're joining to a very large table. And just because of my data warehousing backgrounds, I tend to think of these as fact and dimension type tables, but it doesn't necessarily have to be. But essentially push to the scan of the fact table, which is where like the vast majority of the data is, have that actually get all of the information it needs to be able to do the aggregation right there. So it needs to know what groups things are coming from, as well as the filtering. And so that's kind of what the key vector is trying to do.
Great. Yep. And I just had another recap slide. Kind of the advantages are that since we're going to do all of this in memory during the scan, we can typically get significant performance boost. And realistically, analytic queries, which is what database in-memory targets, are all about aggregation and aggregating data and trying to sift that data to find answers to your business questions in the data you've got. And so it all flows pretty nicely. Again, just to reiterate, this is a database in-memory feature, but even if not all of your tables are populated in memory, it's once in-memory is enabled, the optimizer is free to combine data. Maybe it does. Maybe you have some smart scans if you're on Exadata. It can, obviously the fastest way to do this is everything's populated in the column store, but it's like other features of database in-memory. It's flexible enough to allow you to combine data if you don't have all of your data populated in the column store. It doesn't mean that the queries won't run, it just means they won't necessarily run as fast. And if you have Exadata, if you're able to do smart scans, we can combine that and still, as I recall, we still push key vectors can leverage in-memory aggregation, even with a combination of, say, Flash, which we support the database in-memory formats in Flash on Exadata, and in the column store. And Ekrem's nodding his head, so I didn't screw that up. So I think I got that right.
Yes, well done. Yeah, and actually in that case, we're able to even push all of the, both the join, the grouping, and aggregation. All of that can be done actually on the storage cells. And this is in later releases, not in the initial release of IMA, but this is one of the.
So that would be, so 12.102 is when in-memory aggregation with database in-memory first came out. So then in later 12.2, 18C,
so
19C.
12.2, I might get some of the details wrong, but I think it was 12.2 we pushed the key vectors there to get filtering on that. In 18, we also started pushing aggregation and enabling aggregation to also be performed on the cells. And in 19, we started to look at various limitations and situations where, for example, if you have a larger dimension table that you're joining to, it kind of previously would cap out at a certain point, and we kind of have been expanding how much, by doing things like compressing the key vectors before we send it to the cells and things like that.
Great. That's good information. And then this is another slide that I tend to use, but really the only point of this is just kind of just to show that it's not just two tables. So, and I won't spend too much time on this, but it is interesting, and I'll show you in one of our execution plans that Oracle traditionally joins two tables at a time, but one of the advantages with in-memory and hash joins, and certainly with in-memory aggregation, is the ability to combine multiple tables and join those or scan those against the larger fact table, if you will. So it's very well suited to star queries, OLAP type applications, which, and you're in actually the more traditional OLAP group, right?
That's right. So previously to working on in-memory aggregation, and still to some extent, my group worked on the OLAP, Oracle OLAP option, and which was basically a multidimensional database aimed at providing real-time query capabilities and analytic capabilities. But it suffered from the problem that you had to have, like, you weren't querying a table, you had to take the data out of the table and put it in some totally different, storage thing. And as we saw database in memory coming along, that was providing like a lot of the things that we needed to be able to perform very similar sorts of optimizations with no, also another problem with the OLAP option is you had to pre-aggregate everything and define very carefully, what are your dimensions and all of that sort of thing. This gets away from all of that and allows you to, you just write a normal SQL query and behind the scenes will rearrange it and sort of push all of this processing right down to the fact scan. And I'm sure, Andy, you've talked in the past about how there's database in memory like has the ability to aggregate as part of the table scan. Right. And IMA basically uses the key vectors to accomplish using exactly the same code path.
So we can avoid pre-computing these multidimensional cubes or temp tables, and that fits with our goal of saying real-time analytics, or being able to do run your queries right on the source data without having to know ahead of time exactly what queries you're going to run.
Yeah.
Huge advantage to database in memory, and obviously in-memory aggregation, helping that story go along. Okay. You know what? I just had this thought that when I put all these together, I didn't really wasn't sure how all this was going to flow. So I thought maybe since we've spent so much time talking about hash joins and aggregations, and actually, you know what? I'm going to even dispense with this, and I'm going to roll right into the demo, just so that we can use an execution plan kind of to visually kind of talk about this. We've mentioned key vectors now. We've mentioned vector GroupBy. So what is all this stuff? So this is just the normal set of queries that I run, and hopefully my VirtualBox will stay up, and we'll just run this. And kind of some of you that have seen our demonstrations in the past, this will be somewhat familiar. But bottom line is we just have a SSV schema. We have our line order table, which is the larger fact table, and multiple dimension tables. So we have 4 dimension tables. Oops, didn't catch all of that. And we're just doing an aggregation, looking by year and nation, looking for profit, just kind of a query to run. And it runs very fast. But the interesting part, I think, would be we just spend some time kind of looking at the execution plan. And one of the key points, obviously, is this whole vector GroupBy portion, which is ultimately in-memory aggregation. There's a little bit of setup at the beginning, and the key points I would just make, and I'll let Ekrem, you take over. But the fact that we're actually able to scan the dimension tables ahead of time, create these key vectors, which are functionally equivalent to Bloom filters from the join perspective, but also give us dense grouping keys so that we can do the aggregation in memory. And if I screw this up, let me know. And
then, that's exactly right.
And then we are able to apply those, again, very similar to what we do with Bloom filters on a normal or a traditional hash join, or an in-memory hash join, I guess is a better way to put that. And then we access the line order table. So we haven't broken some rules, but I always like to say we kind of cheat in the sense that in-memory gets the ability to use a slightly different execution plan within the optimizer can create a slightly different execution plan and is able to do all of this work, the scanning, the actual join comparisons of the dimension tables, and then the aggregation during the scan of the line order table. So effectively, we accomplish our goal, which is to do all of the work during the scan and filtering operations of the tables in memory and produce a result. And so I'll shut up and see if you have anything you want to add to all of that. And I can just tell me if you need me to move up or down in this execution plan, since it looks like it's just a little
Sure. No, I mean, I think you covered kind of the main points, I would say, from a like which parts of the plan are doing what thing. Oh, it looks like interesting.
So I had that in a couple of the slides. If you want me to go back to that.
No, I'm happy to just talk through it. Okay. So I was trying to find like the annotate, but it looks like it's not available to me.
Oh, it's not?
That's fine.
Well,
no, it's okay.
Sorry. Okay.
It's fine. It's all good. So if you just like essentially when we start this plan, as Andy said, the first thing is we need to, in order to be able to push these things to the fact scan, we have to be able to, or to the scan of line order, I should say, we have to have kind of created the key vectors beforehand. So the whole reason we go through this temp table transformation thing is in order to produce the key vectors beforehand. So the key vector, it basically, you can think about it as like in these examples, I forget what the grouping column of date dim was in your query, but it looks like it was probably year or something like that. That's right. So in this case, what we're doing is basically, so there's, in the date dimension table itself, there's 7 distinct years, and we can tell because of the number of rows in the, maybe if you could go up just a couple lines, Andy, to show the headers. Yeah. So there's 7 years you can see like on lines 2 and 3 and 4, I guess. Those are, the 7 distinct years. So essentially what the key vector is doing is it is saying, instead of knowing, the year value, whatever it was, 2004, what we're going to do is we're going to just remember this value is 0. And so it kind of takes those things and it densifies them into just a small number of thing. In this case, because there's less than 8, we can use 3 bits to represent it. And we kind of compact it into a small representation. And then we have kind of a compact representation of all the information we need to be able to perform the grouping. And then we also create this temporary table, which I guess in this case is like, the names for these are always incredibly long, but 64F or something. And then you can see it getting joined back at line 27. So essentially, after aggregation is complete, we're going to go through all of the thing and get the real column values, and that's just joining using the dense grouping key as a join key.
Right, so you basically create symbols that are very dense and compact, and then those can be pushed in, and then at the end, when you have the results, you can associate those grouping keys, if you will, with the actual value, right? Exactly. And it avoids having to then revisit the dimension table to pick those values up, correct?
That's right. That's exactly right. And all of this is pretty much a numbers game, because the situation, this makes kind of all these additional steps make sense based on we're looking to optimize situations where you're joining a very large table, line order, to much smaller tables, date. So like in this case, there's less than 1 million rows in each of the dimension examples. And so that's, we're willing to spend this extra time kind of making this compact join representation and pushing it to the fact, because then when we're evaluating, looking at each of the 41 million fact rows, we can make it much, much more efficient.
So somebody might ask, well, why don't we do this for all sorts of normal joins? And I think you hit on it there, is because in general, this step, we're willing to sacrifice memory or creating memory, doing that work and storing that data, because we know it's small. And that's how we can get away with doing doing this application here, correct? I mean, it's a memory game too, right? A numbers game, memory game is trading off that we'll do a little work ahead of time because it's so much faster in the end result, right?
That's right.
Way to look at it.
And all of this kind of fits under the umbrella of a cost-based transformation, which we call vector transformation. And that's the thing that sort of looks at, a plan. It says, would the IMA style plan apply to this query? And if so, it says, okay, if we, it tries to look at making that transformation, and then it just costs that and compares it against the non-IMA plan that would kind of be the plan of record. So based on what the optimizer thinks the cardinalities for the various tables are, if it fits, it will, choose this plan.
So along that same, can you explain, we talked a little bit about this, and I've mentioned it in the past when I've talked, but what that guy's doing?
Yeah, sure. So vector group by, I didn't really explain it this time. Essentially, given all of these dense grouping keys, which are kind of, after you've done all the key vector use, you can think of it as your row vector will be like dense grouping key after dense grouping key. And what those get used for is just identifying like which bucket of aggregation it's a given row is going to go into.
Yeah, so I don't have the slide.
That's okay.
But it's it's this area right here, correct?
That's right.
Referring to?
That's exactly right. Yeah. So I mean, much like that, in fact, that picture is a very accurate representation of what we're doing. One of these would be kind of the dense grouping keys coming from the footwear table, the other being the dense grouping keys from that outlet table. In one case, there were 3 of them, and in the other case, there are 4. So there's like a little grid of 12 cells in this space, and each row gets assigned to a cell and dropped in there. We did this because it's much faster. You don't have to compute hash functions. You don't have to do any of that stuff. The problem is, as Andy said, it's kind of a memory game. If you have a very large number of dense grouping keys coming out of things, you can end up in a place where it would be too much memory to be efficient. And then in that case, we just fall back to hash group by for it. So vector group by sort of steps out of the way, and hash group by completes the work.
I think I've only seen that a couple of very rare cases, but then I don't live in the real world per se, but I have seen where this will take over and you'll get values, different values in this area, as opposed to it flowing through, I guess is the way to put that for the
That's right.
plan.
Yeah. So what I typically have seen is that basically the vast majority of plans that we end up optimizing from different sources tend to have a very small number of dense grouping keys coming out of any given key vector. Like 95% plus are fitting within 1 byte per grouping value.
So dense, very small.
Right, exactly. The time that you can, it's not uncommon to see plans that have, 16 key vectors. And then even if you have a small number for each one, you can kind of rapidly run into the place where you need to use hash group by because,
I'm just gonna see if that helps my light shining on my window right there, shining on my face. So one of the other things we talked about and thought would be worth mentioning, let's see if I have one in here. So this kind of just describes again what you basically have just talked about. Was this guy right here. So can you talk a little bit about, and I've noticed this,
Sure.
where I find when I'm either working with customers or doing demonstrations that as we've gone later in releases to 19C and 21C, that it seems that vector group by pops up a lot more often than, sometimes it messes up some of my demos just because I'm looking to see a hash join the Bloom filters and boom, it just ran so fast. Sorry. No, that's what it's supposed to do, right? But with a vector group by, so how have you guys, or what have you learned, or what's your group learned over the releases with Vector GroupBy?
Yeah, so there's essentially two things that have happened there. One is, as time has gone on, we've been pushing more and more operations into the table scan itself. And kind of associated with that, the performance has been getting better and better for IMA. And we've started sort of looking at where we've been getting, we have a whole battery of tests and, things that we've seen from customers and other such things that, show where we're getting it right, where we're getting it wrong. And we've kind of we were actually very deliberately extremely conservative in the first release. We wanted to make sure that, it engaged only when it was exactly like the perfect query. And if it engaged, it was not going to cause any trouble. Because, just that way you're not causing any trouble. Over time, you can get it more accurate about when the right time is. But, we didn't have time to fully study, all the possibilities in that first release. And plus there were optimizations we knew we wanted to do, but couldn't do in that, first release timeframe. So over time, we've improved the performance and correspondingly kind of optimized our costing so that it is more accurate. And then the other thing we've been doing is over time, we've just added a lot of additional query patterns that we didn't used to support. So for example, in the first release, if you had count stars, your only aggregation method, we said, we're not going to do that query. We don't know anything about it. But that's a pretty common thing. And, we said, OK, let's optimize that one too. And similarly, if you have an expression that spans, like you're doing a sum of a column from the dimension from a table that has a key vector on it, as well as the fact table, you end up in a situation where, like previously, IMA could not handle that because, we only have the dense grouping key. We don't have the value of any other columns. So we added a capability where essentially other column values or expressions that are derived only from the one of these smaller dimension tables can get bundled up with the key vector and pulled in kind of as needed to do that. And then coupled that with, I think that went in 18, and then in 19 we had further optimizations there that included, being able to continue using the IMC aggregation things as well as all that. So basically making sure everything was pushed down to the table scan and making maximum use of SIMD and all of that good stuff, kind of improve the performance of that. And then, so count distinct, we have been improving support over time. We're continuing to, so for example, in 21, there's sort of more optimizations for queries that have multiple count distincts, and we're pulling that into IMA and all the rest as well. So there are plenty of
continuing to develop and improve.
Exactly. Yeah.
So that goes along with a lot of the other things and features in database and memory. We're also I've been doing a 21C new features, a set of presentations, and actually there's a lot of new features, and so I guess I should, we'll use this as our 21C, so in-memory aggregation doesn't get left behind. It's also being improved, right? So
right.
Yeah. Well, and it is a learning process, right? Because
definitely.
as you see what customers are needing and where perhaps the things aren't being, or maybe you decide that, we could do that, and so
exactly.
It goes into the code. So
one of the things that often comes up is some benchmark, like recently there was attention on TPCDS and like places where queries could be improved by applying IMA more aggressively and in different scenarios that we hadn't thought of. So that's another set of things we did in the 21 timeframe.
And I guess we should mention that because it ultimately is an optimizer decision based on cost and parse time analyzing the query. And there are hints, right? I mean, there's a no vector
Yes.
transform hint and a
Yes.
vector transform hint. So even customers that aren't seeing a vector group by because maybe the statistics aren't quite right, or maybe the optimizer for whatever reason hasn't chosen that, they could try a vector transform just to see if it's better, even though the optimizer might not choose it, because it is still Oracle, right? You get, there
Yeah,
would be
sure.
Oracle without hints and all the rest that go along with it. So
That's right.
Yeah.
Yeah, and you can also, control individual tables, say, oh, that's a dimension, that's a fact, that kind of thing as well.
And I guess now we're going to go off the reservation a little bit, but how analytic views can also leverage this, right? Because analytic views allow you to define the dimension hierarchies, and then the optimizer understands that, and then does that go hand in hand with in-memory aggregation?
Yeah, it does. I mentioned earlier our group had like an OLAP focus. And so essentially what happened is we kind of split into, we're still in the same organization, like both halves are reporting in, but like there was one team that was focused on the IMA and that sort of thing. And then additionally, there was a team focused on analytic views and kind of adding the expressiveness type capabilities. And because we, work together so well, it was seen as very much complementary to enable, the same sort of analytic applications to be developed without all the overhead that the OLAP option had. So
I'm trying to remember. I think analytic views, I don't know if it was 12.1 or 12.2 when analytic views were, if you're not familiar with analytic views, I realized as you were speaking, I should have probably qualified that a little bit more. But analytic views was another addition to Oracle database that allows you to define, again, hierarchies. So it gives so rather than the optimizer trying to infer hierarchies, you can tell it. And so then that makes its ability to parse that data or parse that query a little bit easier. And then it can leverage, since it's all bundled together in the sense that we're all fully integrated, it can, if it was maybe selecting a parallel query would be the same kind of idea, where it knows that it has these transformations, if you will, available to it, and it could then leverage vector GroupBy in conjunction with that. So folks could avoid pre-computed cubes. Again, the whole going back to the idea that we try to talk about, which is real-time analytics and running right on the source data without having to pre-compute temp tables like the old days. And people would denormalize or combine, trying to avoid the expensive part of the query by pre-computing it, and then lopping on maybe some of the other tables attributes to create a query. We can just do all that within in-memory because it's so much faster and can access that data right as we're scanning it. So that's my pitch, I guess, for analytic views and in-memory aggregation and the OLAP part of the analytic workload, if you will.
That's right. Yeah. And all of that stuff, as you said, it's very complementary. The IMC storage, like it's not like 100% required, but it certainly makes huge difference in terms of, optimizing all of these things, just because we have worked very closely together during this whole thing.
Yeah. And then I don't see that many customers that are super aware of analytic views. So I always do like to kind of mention that when we're diving into all this the high performance kind of options of in-memory, because there are so many features of Oracle database that most of them are used automatically, like in-memory aggregation is, once you enable database in memory, it's just going to get used. But then there are things like the other one I can think of is zone maps, analytic views. There are certain technologies, even for us join groups, we don't automatically create join groups yet, but there are these other features that you do, if you're aware of them, can, for certain types of queries, can really be advantageous. So okay, what else did I'm thinking we've covered, kind of went through all of this for the execution plan. And I always like to point out that our blog, I know, that's reminding me of the other thing I wanted to mention, but our blog, blogs.oracle.com in-memory, we've now come up with, the format has been changed in the Oracle blogging environment. So you'll notice that things look a little different than they did in the past, but our resources page is still there. And although you can't read any of this, well, maybe you can, but in there we have lots of information, technical briefs. Like I mentioned, we have a Live Labs environment, our AskTOM link, YouTube videos. One of the things that's in here is a white paper called In-Memory Aggregation that got written back in the 12.1 days that goes through all of the kind of the deep technical issues that you kind of talked about already. But and here's my plug. It would be nice if we could update that. So maybe we could, and I think everything that's in that paper is relevant, but maybe there's a few tidbits that I could talk you and Bud maybe into helping me update. We could create a new version of that based on what we've talked about today and what we talked about previously. But if you are interested in more about in-memory aggregation, I would suggest that white paper is another excellent resource to take a look at the motivation and how this all works. So, and you're nodding your head, so I put you on the spot, but I'll follow up with you and see if we can do
Sounds
something.
great.
I won't hold your feet to the fire here, but that was one other thing I did want to mention to folks, that there is another more technical, not more technical, but another resource if you want to learn more about the technical aspects of how vector GroupBy is working and how you might leverage it with your applications. So, but anyways, okay. So I don't see any questions, but if you have questions, please feel free to put them in the chat. And while we have Ekrem here with us, or if you have other questions about database and memory that you want to ask, we'll hang out a little bit, but we've done pretty good. I've been trying to keep our sessions a little shorter, and we've still gone over, but we're not at a full hour, which is okay. But I do want to make sure that any questions folks have had, and if you're shy, or if you don't remember, or maybe later you go back and look at the video, or maybe you look at the in-memory aggregation tech brief, feel free to email me. If I don't know the answer, I will see if Ekrem knows, or maybe if it's a different type of question, one of our other developers. But the idea here is an office hours, so we're here to answer your questions. Why can't I see?
So I do see there was a question about, are there any prerequisites to use in-memory aggregation?
Yeah, there you go.
And so the major prerequisite is you need to have database in-memory activated, which means setting the in-memory size to some value. You don't necessarily need to load the tables in memory, just having in-memory size set to a non-zero value kind of serves as a flag.
Right, and actually in 21C, you could just set cell memory, which I think will still kick that in. But realistically, to get the full advantage, you really want to have the column store enabled. But I think the takeaway is that in memory, one way or another, needs to be enabled to take advantage of this. But as we said earlier, even if not all of the tables are populated, you can still take advantage of in-memory aggregation. And in the case of Exadata folks with smart scans and the ability to do during a smart scan, or if that data has been populated in Flash, you can take advantage of, there are certain push downs, I think you said, that still can occur. So
yeah, that's right.
So I've got the Q&A up. Oh, there's another question in the chat. So we can make sure we catch all of these.
Yes, it can be run. In-memory aggregation, the question was, can in-memory aggregation be used with regular tables? The answer is yes, it can. It will not have as much of a performance benefit, because a lot of the benefits it gets is from kind of pushing the join-in aggregation down to be able to run these sort of making use of the key vectors on top of the in-memory formats. So just to use a specific example, like from the SSB environment we were looking at before, line order is typically partitioned by month or something like that.
Okay.
And so any given set of blocks that form a compression unit will only have like 31 or fewer distinct values. And so essentially we would be analyzing the join step only for those 31 times, and then making use of that as we do aggregation across the full range of things. So that optimization can be quite powerful in terms of speed up. And obviously, you would not get that without database in memory,
Right,
or IMC storage format.
all right. Well, if we don't have any other questions, we'll give you back about 15 minutes of your day. Ekrem, I want to thank you. It's been wonderful having you.
It's a pleasure to be here.
It takes pressure off of me trying to remember all the details. You know all the details, and it was I think it went very well and very fun to do that. And thank you everybody for attending. And this we will post the recording of this, and we will probably not have an office hours session in October. We have a bunch of I have a bunch of presentations and conferences that I have to deal with, and this does take some time. But in November, my plan is to talk about or revisit in-memory expressions, mainly because in-memory expressions are being leveraged under the covers for a bunch of our new 21C features, including JSON support, graph, spatial, which we kind of touched on in 21C. So I thought it would be fun. I'm going to invite our developer, who is the main guy that developed in-memory expressions, to come speak, and just like Ekrem did today, and maybe we'll learn some more details about how all that works and how we're leveraging that with newer features of Oracle database and database in memory. So that's my plug for our November office hours. Again, Ekrem, thank you so much for being willing to come.
Thanks for having me
and visiting. And with that, I will say goodbye, everybody, and see you next time.